All right, welcome to the Chemical Reactions unit for Honors Chemistry. So as you can see by this first page, we are going to focus on chemical reactions this whole unit. We are just going to jump right into balancing chemical equations. So we're going to talk about kind of the different types of chemical equations, how you might see them written, and then just how to balance them today. That's our essential question. So types of chemical equations. There are all sorts of different types or different ways that you can write it. And you're probably familiar with like 2 or 3 of them, but you might not be familiar with all of them. So in a chemical reaction, new substances are formed. Chemical equations are the language of a chemical reaction. So that's how we write them out. Instead of using words all the time, we'll use symbols to describe what's happening. So there are 6 ways to write the same chemical reaction as an equation. And the first one is just a word equation. And you're going to get some of these where I'm going to give you the words and you're going to write down the formulas. So lead 2 nitrate and potassium iodide solutions react to form solid lead 1 iodide with potassium nitrate solution. So using those words, you can then write a chemical equation for that. And what you would write would be the skeletal equation. Skeletal equations are going to identify only the compounds. So what you're going to see in a skeletal equation is just the symbols. So I know you can't see it down here, but it's just going to be the symbols for all of these. So that's a skeletal equation. That's what we'll start off with. A balanced equation is what we're going to work with today. That's where you identify and you quantify the amounts. So we're going to put coefficients in front of things. So you'll have the basic skeletal equation as we did before, but now we're going to balance it to make sure we have the same number of atoms of every element on both sides. There's a molecular equation which contains the states of any of the compounds. So up here we don't have any of the states listed, but in the description, the word description, it told us the states of things. Some of them were solutions, which would be aqueous, and some of them are solids, which you would write an S after. So in that case, you could go ahead and fill in what was aqueous and what was solid based on what it told us in the word equation. The next type of equation is what we call a complete ionic equation, and it's going to show all of the ions, all of the compounds that are present. Pretty much this is just a balanced chemical equation, except we break everything apart. So this is going to show that there was lead nitrate and that there was potassium iodide. And we break apart everything that's aqueous because that's what that means. It dissolves in water, so it's a solution. And this one we leave together because it forms a solid. When we talk about how to write net ionic equations, you'll learn all about this. And so our last type would be the net ionic equation. That's where instead of showing all of the ions, you only show the ones that are reacting. So you get rid of the spectator ions, the ones that are the same on both sides. So see how like NO3 and NO3 are the same on both sides, potassium and potassium are the same, but PB and I are different on both sides of the equation. So that would mean that PB and I are the ones reacting. All the rest of them are just kind of hanging out, not really doing anything. They're spectators. But when we do net ionic equations in a few more days, we will go through and learn how to do this. So each way of writing a chemical equation has pros and cons. There's different chemical equations are better for different chemical reactions. So if you're doing something that's an ionic equation, a net ionic equation might work. So you'll be instructed which type to use, but most of the time it'll be, here's a word equation, write a skeletal equation, and then balance it. So you'll just have the balanced complete equation. Okay, so deciphering word equations. How can we do this? You have to rely on what you've learned in our nomenclature unit. So we're going to have to go back and you're going to have to review your naming rules. If you are unsure of them, I would suggest going back to review that unit on naming. So you're going to start with the stuff in words and then you have to write down what the formulas are. Our basic format is you're going to have things that react together and they're going to yield new things. So reactants yielding products. You might only have one reactant. You might only have one product. But and means that it's the plus sign. It means that this is reacting with this, or this and this are reacting together. Yield is the same thing as saying it produces, it forms. It's just what we replace with the arrow. It's what you would put the arrow in for. And so you lead to, reactants yielding products. There's some signal words to pay attention to. They might tell you the states of matter. Watch out for our diatomic elements. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. These guys, when they are by themselves, they exist as pairs, and we'll talk about them in a little bit. So solid means S, meaning it's going to be in the solid state. L means liquid. G means gas, and then aqueous means that it is dissolved in water. So if you see AQ on something, it just means that it's dissociated. It's dissolved in water. It's broken apart. So I want you to practice these equations. Go ahead and do them on your note sheet, and then we're going to do them in class. So I want you to practice writing the states and just writing the formulas for them. So there are there's 8 of them for you to go through and practice before you come to class tomorrow. So counting atoms, just a little bit of a review on how to count atoms, what these things mean. We need to be able to do this so that we can balance an equation. So if it's written once, that implies that there's 1 atom. So in this sodium chloride, there would be 1 atom of sodium, 1 atom of chlorine. So you'd put 1 and 1. H2O, this subscript down here means that there's 2 atoms of hydrogen and 1 atom of oxygen. H2SO4, there's 2 of hydrogen, 1 of sulfur, 4 of oxygen. When you see parentheses around something and a number outside of it, that simply means you just have to distribute that to everything in there. So that means there's actually 3 NH4s. So we're going to have 3 total nitrogens and 12 total hydrogens, 1 phosphorus, and 4 oxygens. This one down here, you would have 2 nitrogens, you would have 8 hydrogens, 4 carbons, 4 hydrogens, and 6 oxygens. Go ahead and try this challenge one and see how many carbons and how many hydrogens are in this equation. Okay, so balancing chemical equations. That's kind of the nuts and bolts of this screencast. So when you are balancing a chemical equation, you're describing the reaction, but you're also following the law of conservation of matter. You cannot destroy or create matter, so you're going to have the same number as well as the same types of atoms on both sides of the equation. So if you look up here, I have carbon on this side. I have to have carbon on this side also. If carbon is a reactant, carbon better be a product. If hydrogen is a reactant, hydrogen should be somewhere on the product side. I can't have elements in the reactant side and not have them on the product side or not have them accounted for on the product side. And if I have 1 atom of carbon on one side, I better have 1 atom of carbon on the other side. So I'm going to have to balance these things to make them the same on both sides. But the biggest or most important thing that you have to remember is they can only be balanced by changing the coefficients in front. I'm going to put numbers in front to change them. I'm not going to change formulas. If I change formulas, then I change the reaction. So I'm not changing the compounds that are involved. I'm just changing the coefficients in front, meaning instead of only 1 of those, I now have 2 of them reacting. So they have special symbols to indicate physical state. If a catalyst or if energy is required, you might see those things like written on the line, or you might see the states, indicated within the reaction. So coefficients, these are the big numbers in front. They get multiplied by the entire compound. These are the large numbers in front. They indicate how many of that compound or how many groups of those compounds do you need. And that number tells you moles, which that's going to be very important for our next unit. Having a balanced chemical equation is what you need to do stoichiometry, which is relating to moles, the amounts of reactants and products. So the coefficient just tells you moles, but they are not subscripts. Subscripts tell you how many atoms there are within that compound. The coefficient in front tells you how many of that compound you have. So subscripts don't change. The coefficients change when you're balancing, but not the subscripts. So balancing equation steps, if you just follow a few basic steps, you'll be able to balance any chemical equation. Count how many atoms you have on each side of the equation. It may already be balanced. If it is, you can place a 1 in front of all the coefficients so I know you checked it. You don't have to do this. You could just leave them blank because it's an implied 1. But if you want to make sure that you've done it, put a 1 there. Select one of your elements and balance it completely using coefficients only. Select another element and balance it completely. And you're just going to keep going through this until you get all of the elements within an equation balanced. Now there are a few hints that are going to make your life a little bit easier. Leave the simplest elements for last. So like if you have oxygen by itself or hydrogen by itself, leave those as your last elements to balance. It will make your life a lot easier. Count polyatomic ions as a group or as a unit as long as they're on both sides. So if you have NO3 on one side and NO3 on the other side, don't break that apart. Just keep them together. And then another tip is if you can't get a diatomic element to balance, like if you're ending up with an uneven number, just double it. And if you double that, then double everything else. And that'll turn it even so that you can balance it. Those are going to be, that's one of the things you have to do for all combustion reactions. Okay, so I want you to go ahead and try these practice problems. So like in this one right here, count the number of aluminums you have on both sides, count the number of oxygens you have on both sides, and see what coefficients you have to put in front to get them to be the same. This one right here, if you have PO4, see how PO4 is together on this side and it's together on this side, then keep them together. So I have one PO4 here and I have two PO4s here. This one, I would balance oxygen last. I would save oxygen for last. I would do oxygen last here. I tend to do metals, nonmetals, polyatomic ions, and then oxygen and hydrogen. So after we're done balancing, the next thing that we're going to learn how to do is identifying the reaction type, but we're not going to do that until you've got a firm grasp of balancing. So practice balancing these, and then we're going to do some more practice in class. So what are some evidence that a chemical reaction is occurring? When I mix two things together, how do I know a reaction is actually happening? You might have release of a gas. That's called effervescence. Like carbon dioxide is going to bubble off, or hydrogen gas will bubble off. That tells you something's happening. Formation of a solid, that's a precipitate. So if I have a solution with silver ions mixed with a solution of chloride ions, I'm going to get the solid silver chloride that's going to settle out of solution. Heat might be produced, so it might get hot or it might get cold, and that'll tell you that something is going on. A color change, if something changes from like light blue to a yellow, that tells you something is going on or something is happening in there. Some subtle indications that a reaction is happening. You might have heat or light is absorbed or emitted, so something might glow or give off light. It might give off a little bit of heat, so much or so little you might not even be able to feel it. Changes in the way the substances behave in an electrical or magnetic field. So something might be magnetic before, and then when you react it together, it's not magnetic anymore. Like iron and sulfur mixed together is still magnetic. If I heat it up, the compound that forms is not magnetic. Or changes in the electrical properties. Just will it conduct an electric current or not? So go through the example practice problems, and we will review balancing chemical equations in class.